In this video, we're going to look at the foundations of math, and we're going to try to answer the question of what even is math. So let's jump into it. So the way I break it down is to four base components of math. So the first one is numbers. That's the most common one that people think of when they think of math. Then we have operations, algebra, and the coordinate plane. And so pretty much anytime you're encountering a math problem or anything to do with math, you're going to have at least one of these concepts in it, or most likely two or three, or sometimes all four. So let's jump into the first one, which is numbers. So a number is anything that lies on the number line ranging from negative infinity all the way to positive infinity. And then right in the middle, we have zero. So let's go towards the negative part. Let's start with a big number on the negative part. So let's just start like negative 1 million would be a high negative number, but you can keep going bigger and bigger than that down on the line. So let's now move a little bit closer to zero. So you could also have a number like negative 10.5 or negative 10.5, which is close to zero, but if it's on the left side of the number line, it's still going to be a negative number. Let's move over to the other side of zero, and let's look at a number like 20 2/3. So numbers, they can be whole numbers, they can be fractional, just wherever it lies on the number line, that is the number. So there's 20 2/3. And let's go with a big positive number, a whole number to finish on this. And then let's just end it with a positive 1 million would be example of a big positive whole number. So that's just a basic run through of what a number is. And now let's go over what operations are. So an operation is any operation that you perform between numbers. So the basic one would be adding or subtracting. Then you have multiplication, division. You have an equal sign that actually performs an operation. And then you have parentheses and exponents. So let's look at an example of how operations work at a base level. So we got 5, and let's say we're going to add another 5, and that's going to equal 10. So in here we have two operations. We have one right here, the addition, and then we have one right here, the equal sign. So that's two operations resulting in 5 plus 5 equaling 10. Let's try another one. Let's do another basic one. Let's go 5. This time we're going to subtract 2, and that's going to equal something. So there's our operation, so 5 minus 2 equals 3. So operations typically are performed when there's a lot of them in one expression. In this order is the typical one you see, which is PEMDAS. So first you would do parentheses, then exponents, then multiplication and division, then addition, subtraction. I'm going to go one step further and add one extra thing. And this one's, it doesn't sound quite as nice, but it's more realistic for how expressions are performed. So the first one still is parentheses. The second grouping is going to be exponents, roots, and logs. The third grouping is going to be multiplication and division, and then the final grouping is going to be addition and subtraction. And so think about this ranges from the complex operations all the way down to the basic. So you got parentheses or grouping together is the one you start with. Then you have the more complex exponent, roots, and logs. Then you got multiplication, division, and the most basic operations are addition and subtraction. So think about it almost with this pyramid where you have at the bottom addition and subtraction. Built on top of that is multiplication and division. Then exponents, roots, and logs are built on top of multiplication and division. And then finally at the top, parentheses aren't necessarily complex, but it just means that something is grouped together. So again, think about it from the same thing. We got basic operations to complex. So a good definition for operations would be that it's an interaction between numbers. Another way to think about this would be non-number buttons on a calculator are always operations of some kind. But there is one that is separate from all the other ones, one that's just a little bit different, and you can think about it as one operation to rule them all. And which one is it? Let's see, the drama is crazy. It's going to be the equal sign. The equal sign is the one operation that is much different than all the rest because it is the separator. Meaning wherever you see the equal sign, you should automatically look, there's going to be two sides of an equation, and it means they equal each other. And there's actually 5 types of separators. So there's less than or equal to, greater than or equal to, just less than, or just greater than. So anytime you see any of these symbols, all your brain should think is, okay, this is where the equation is separating itself into two parts. So So if we have our pyramid here, really at the base of the pyramid is not addition subtraction, it's actually going to be our 5 separators there. So that's the first thing you should look for in any equation, is try to find where the separator is. So that's a basic run through of operations. So we've covered numbers, we've covered operations, and now let's go over algebra, which is what this class is actually about. So let's go dive into what algebra is. So algebra deals with variables and functions. And so the way that I think about algebra is think about it of the science of 2 sides. So you have side 1 and side 2, and then there's your separator, which cuts it in half. So it can really be written in many different ways. So you could have something like y equals x. You could have actually an equation 12 equals x plus 7. You could have a more complex equation like 196 equals 3x squared plus 4. And at the end of the course, this is an equation that you should be able to solve, but we're not going to expect you to do that right now. So let's take a look at this equation. And so what you're trying to do in algebra is the goal of algebra is to isolate the variable. And once you have your variable isolated, that's going to be your answer for x in this case. So again, look at this equation. You'd cut it in half, and our end goal, where we want to get to, is going to be this. So 8 equals x. So that's the answer to this equation. And what that means is literally what it says. It means x equals 8. So that means that you should be able to plug in 8 where x is, and then it should equal 196. So you plug it in and verify that both sides equal 196. So let's do that. So again, in our yellow, it says side 1 is 196, and then we have 3x squared plus 4, so it should equal 196. So let's plug in 8 for x and c. So we got 196, and then we do 8 squared is 64, so we got 3 times 64 plus 4, so we got 196 equals 3 times 64 is 192. So now we have 196 equals 192 plus 4. So when you add that together, what you have is 196 equals 196. And now the equation is verified. So that is what our goal of algebra is. But the question is, how do you solve it? How do you get this answer of 8 equals x? And that's what we're going to learn throughout this class, is how to perform these operations to get to this answer. So if the order of operations is PEMDAS, the way you solve algebraically is actually the reverse order. So you solve it in order of SAD-ME-P. And we will go over this in more detail, obviously, later in the semester. This is giving you an idea of how it works. So that's a quick run through of algebra. So we've gone through numbers, operations, algebra, and now let's finish with what is the coordinate plane. So coordinate plane, we have our x-axis, which is our horizontal, and our y-axis, and this is what it's going to look like. And let's zoom in a little bit, and let's give it a grid. So there's the x-axis grid, and let's finish it with the y-axis grid. So we're going to change the color of each axis so we can separate them. So we're going to have the y-axis be yellow and the x-axis be blue. So the way the coordinate plane works is, let's look at some coordinate directions here. And so the way a coordinate plane is structured is the first thing that's labeled is always going to be what you do on the x-axis, and the second number is always going to be what you do on the y-axis. So always remember x is first, y is second. And always remember that the x-axis is going to be the horizontal axis, the one that goes left to right, and the y-axis is going to be the vertical axis, or the up and down one. And so the origin of the coordinate plane is going to be the point 0, 0 right there. So it's when x is 0 and y is 0. That's called the origin. So let's look at a set of points here. We're going to actually plot these on the coordinate plane. Let's go 3, 2. So let's always do x first. So x is 3. That means we're going to go right 3 spots. So just count 3 spots. 1, 2, 3. So there's our 3 to the right. And then let's look at our 2. So 2 means we're going to go up 2. So there's 1, 2. And right there, that means we went over 3, up 2. That is our point 3, 2. Let's do another point, and let's go back to the origin. And now we're going to do -2, -5. So if it's negative, that means, remember, we're going to do x first. So if it's -2, that means we're going to go to the left 2. So there's 1, 2. And if y is also negative, instead of going up, that means we're actually going to go down 5. So 1, 2, 3, 4, 5. And then there's our point right there, -2, -5. So you just got to follow the directions on the coordinate plane. Let's look at another thing. This time we're going to actually draw a shape. And it doesn't tell us where, but let's just draw a 9 by 6 rectangle. So there's our rectangle right there. And 9 by 6. So that means it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on the x-axis, and then 1, 2, 3, 4, 5, 6 on the y-axis. So there's 9 by 6. So that's a 9 by 6 rectangle. And then that area of that rectangle is going to be 54. So you could go 9 times 6. Or that means if you count up all the little squares in there, that means there's 54 squares. Now let's go one more thing you can do on the coordinate plane, and that's where you can graph equations on this. So we're going to graph a basic equation of y equals 2x plus 1. So that's going to look like this, and what that means is, right here, that's our y-intercept of plus 1, and the 2x means we're going to go up 2 and over 1. So we're just going to keep going up 2, over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2, and over 1. So it's just going to keep doing that infinitely. And so that's just a basic on how to graph equations on the coordinate plane. And we will be going over this in more detail throughout the semester. So those are the 4 components of math: numbers, operations, algebra, and the coordinate plane. And so one final note is everything in math you do from here on out in every class or your everyday life will deal with at least one of these 4 base components in math, and most likely at least 2 or 3 of them.